Hi guys, Mrs. Thompson here, and I'm going to cover the mole today. Um, Anything that I write on the binder paper is what I want to see in your notes. Anything extra, you don't have to write. All right, so here we go. The mole, what is it? It is a unit in chemistry. So we're not talking about the little furry moles. We're not talking about the moles in your skin. We are talking about a unit in chemistry. This unit allows chemists, and you, right, you're a chemist now, to calculate the number of particles in a given amount. Usually when I say a given amount, we're talking about a given amount of mass. Okay, so I could tell you to calculate the number of atoms in 25 grams of copper. Or I could say, here's a penny, find the number of atoms in it. And that's all something you should be able to do using Avogadro's number, or what we call the mole. All right, so this is like a counting number. For example, like if I were to tell you I have a dozen eggs, you would know exactly how many eggs you have. You'd have 12, right? I could tell you you have a dozen cars. How many cars do you have? You have 12. So it's a unit that's associated with a number. Another one, a ream of paper is 500 pieces of paper. So a unit associated with a number. All right. So our unit is a mole, and it's associated with a number 6.02 times 10 to the 23rd. It says particles. So let's figure out what kind of particles can we possibly have. I gave the example of atoms. So like copper atoms, you could figure out how many copper atoms there are in a penny. You need to be able to tell what you're dealing with. So if I give you an element, you would be able to identify it's just an atom because the formula wouldn't have any subscripts whatsoever. So we see neon, calcium, iron, no subscripts. This is just an atom. Okay, if I gave you a representative particle that started with a nonmetal. Oops. So where are those nonmetals? Let's review. Remember, you have the staircase here. Anything to the right of the staircase, those are nonmetals. All right, so I've got this carbon and oxygen. Starts with C. C is a nonmetal. So therefore, this is a molecule. H2O starts with hydrogen. Hydrogen is that sneaky little one atom that's on the left-hand side of my periodic table. That is a nonmetal. Okay. What I have drawn on there. All right, so next one, a formula unit. So these are just ionic compounds that start with a metal. Well, all ionic compounds do, except the ones that start with ammonium, so we're not going to get into that. Those are the ones that start with a metal. For example, NaCl. We have Na, which is sodium. It's on the left side of that staircase. Staircase is here, it's over here. So that means metal. Formula unit. K for potassium. Right over here on the left-hand side, formula unit. Okay, what if I were to look at these? Let's take this off here. Are these atoms, molecules, or formula units? So I need the periodic table again. I'm looking at the first element in here. So K, right here on the left side, that's a metal. As soon as I see that it starts with a metal, I know this is a formula unit. All right, next one, N2O. We're looking at this one. What does it start with? It starts with nitrogen. Nitrogen is over here to the right of that staircase. That's a nonmetal. This is a molecule. All right, what about the last one? I noticed something. It's not in a compound. There's not two elements involved. So as soon as I see that, it doesn't have any subscripts. It isn't bonded with anything else. This is just an atom. All right, so you need to be able to identify these. That way, when you're doing these problems, you'll be able to tell me whether your particle is a formula unit, a molecule, or an atom. Okay. So the next part in this, we're going to be doing conversions with the mole. So I've just told you that 1 mole is 6.02 times 10 to the 23rd particles. Anything where you know an equality, you can make a conversion factor out of. So I've made a conversion factor here. So that 1 mole is 6.02 times 10 to the 23rd particles. So I made this, looks like a ratio, conversion factor. When you solve these problems, there's basically 3 steps. Well, a little more than that. You're going to list your givens, your unknown. I'd like you to list the conversion factor. I know it's an extra step, but it'll pay off later. Okay, you're going to cancel your units. Remember that things that are across from each other cancel. And you're going to round your answer to the correct number of significant figures. Since we're just multiplying and dividing, and we're dealing with a conversion factor, we're just going to base our answer or number of significant figures on the given. So we'll round it to the same number of significant figures as the given has. I'll show you an example so you can see what I mean. All right, so here's our first one. Determine the number of representative particles in 2.50 moles of FeCl3. Okay, the first thing I'm actually going to do before I even start the problem, before I even list my givens, I'm going to figure out what is FeCl3. Is it what type of particle is it? Okay, so remember my options are atom, molecule, or formula unit. It's based on what it starts with. Fe is right here. So it's to the left of this staircase, meaning it's a metal. So starting with the metal, right? Starts with the metal. That's an ionic compound. We're going to say that this is a formula unit. Okay. The next thing I'm going to do is I'm going to list my given, unknown, and conversion factor. All right, so the given is always the number with its unit. So 2.50 moles of FeCl3. So 2.50. I don't like writing the full word moles. Chemists, you'll find it like we don't have a whole lot of shortcuts, so we just put MOL. That's at least one shortcut. MOL moles of FeCl3. It's important that you label not only the unit, but of what. So the substance. So when we get to something called stoichiometry, it'll make a whole lot of sense then. Right now, not so much, but when we get to stoichiometry, labeling that of what is super important. Okay. The unknown, what are we trying to find? It says determine the number of representative particles. So I'm going to put question mark, and I'm not going to write representative particles. I know what type of particles I want to find because I've already figured out what FeCl3 is. So I want to find the number of units or formula units. Let's just put units for short. A little shortcut there, just a little one, of FeCl3. Okay. And then it says conversion factor, CF. We're going to be using the same conversion factor here over and over again. So 1 mole is 6.02 times 10 to the 23rd. We're just going to write that, not the whole particles part, but just that. All right. So that's just me figuring out how am I going to solve this problem. Next, let's go ahead and solve it. So you're going to start with your given over here, 2.50 moles of FeCl3, and you're going to multiply it by a conversion factor, right? We know the conversion factor, this one. It's this ratio, but we have things substituted in that ratio to account for the substance that we're dealing with and what type. Okay. So here's my conversion factor. Remember that with conversion factors, here's what it looks like to start with. 1 mole is 6.02 times 10 to the 23rd particles. With conversion factors, you can flip it so that the particles end up on top and the mole ends up on the bottom. You just got to figure out which way do I want to use this conversion factor so that I can cancel units? Okay, so let's set it up this way, just as is. It might be handy to make yourself a little sticky note just like I did. All right, so if I do this, moles on top and moles on top, when the units are not across from each other, they don't cancel, they multiply. So that's not how I want to set this up. Instead, I want to set it up like this, so that moles are across from each other and that they can cancel. All right, so here we go. I'm going to copy this down as is, almost as is. I'm going to change it so that it's specifically for the substance and specifically for the type of particle. Okay, so 6.02 times 10 to the 23rd. I'm not going to write the word particles. I'm writing what type of particles, units, or formula units, but this is our small shortcut for that. I'm also writing of what? FeCl3, that's the substance that we're working with. Okay. Then I'm putting the 1 mole on the bottom. And the of what? The substance, FeCl3. This should be the same. The substances here should be the same. Okay, this cancels, both the mole and the FeCl3 cancel. Here and here, they're across from each other. They're the same, they cancel. Then we just need to solve this. At the bottom of your page, let's discuss what that looks like in a scientific calculator. Okay, so here's what I wrote. Let's talk about it. You want to get this into your calculator, and there's 2 ways to do it, or just depends on your calculator. This is my preferred method, using the E button, and that's a capital E, not a lowercase e. A lowercase e is inverse natural log. We don't want to do that. So what we want to do is we want to use the E. This is my calculator. This is a pretty common one. We would put 6.02 e to the 23. We wouldn't put anything like that's up. There's no superscripts here. It's just all in one flat line. It looks like this. 6.02 for my calculator. Well, it's not on. 6.02 for my calculator. I have to use a second function to get to that EE. See, it's blue, second E, 23. Now I have 6 times 10 to the power of 23 written in here. The nice thing about when you use it like this is that it keeps it all together. It's like putting it in parentheses. It attaches it in your calculator, and then the order of operations doesn't mess up later. You could, if you are not comfortable seeing that E, use this, the caret method. 6.02, oh, I even messed up. Use parentheses anytime you use the caret method. 6.02 times 10 caret, so this is a little up arrow right here, 23. Close your parentheses. The reason for this is it'll follow some funny order of operations if you don't have the parentheses, because it doesn't group it all together. It might divide the 23 by something else if you're using division. And then it changes it in your calculator to the 6.02 times 10 to the 23 when you hit enter. That little times 10 is really small in there. Okay, so that's 2 ways to do it. If your calculator doesn't have that E function, you could see something like this. All right, let's go back to my problem. All right, when you are solving this type of problem, you multiply the numbers that are across from each other, and you divide by the numbers that are on the bottom. I'm just going to type in everything that I would put in my calculator. Okay, so this would look like this. 2.50 times, let's use the E method, 6.02 E23. Okay, Then I would hit enter. Then I would divide by, take whatever number that is, and divide by the bottom number. In this case, I'm dividing by a 1, and so it's really not necessary, but later you'll see that it does become other numbers other than 1. So be very careful. So whatever this answer is here, I divide by the number here. So divided by 1. Let me show you what that looks like in here. 2.50 times 6.02 e, oops, e to the 23. I hit enter, and I divide by 1. It's dividing by 1, so it's the same thing. All right, so I'm going to write that number down. 1.505 times 10 to the 24. Okay, so now we need to, right, we canceled units. We did our math. I didn't see that as a step. These are just some like things, don't forget to do those things. But now we need to round the number of significant figures to the same number of significant figures in the given. So let's look at the given. The given has 1, 2, 3 significant figures. So my answer needs to have 3 significant figures. Remember, when you round, you start counting at the first non-zero on the left. So that would be here. That's 1, 2, 3. Okay, and then I'm going to decide if the 5 can bump up the 0. We're just going with the rule that if it's 5 or greater, you bump it up. So this would be 1.51 times 10 to the 24. It's not done then, though. I know I have a number here, but it doesn't make sense until you tell me the units and the what. So it's this many formula units, which we abbreviated as units, of FeCl3. I didn't have room to write it here, that's why I wrote it underneath, but if you have room, just write it right next to it. Okay, so a one-step problem. We had scientific notation in here, but we went ahead and used our calculator to help us with that scientific notation. Okay, let's try one more. How many moles are contained in 1.85 times 10 to the 26 molecules of CO2? The given number in its unit, all of it, 1.85 times 10 to the 26. You cannot abbreviate molecules. Do not tell me mole. That has its own specific unit. Don't abbreviate molecules. You have to write it out. The unknown is what we're looking for. So how many moles? So question mark moles. Don't just tell me what, but of what. It's always going to be the same substance. So I want moles of CO2. Okay, my conversion factor, I am still looking for things to be in particles and moles. So I'm still using that same 1 mole is 6.02 times 10 to the 23rd. Still using Avogadro's number. All right, let's start with my given. 1.85 times 10 to the 26. Again, I know you're going to be so tired of writing by the end of these problems, but it helps with your understanding of what to do, especially when it comes to later, when we get to more complicated problems, okay? All right, so 1.85 times 10 to the 26 molecules of CO2 is my given. I multiply that by a conversion factor. Here's my conversion factor. Let's decide which way should I use it. You always want to use it so that units cancel. Right now I have molecules. Molecules is a type of particle. So a particle times a particle, that doesn't, or molecules in a mole, those don't cancel. Okay, so that means I need to flip this so that molecules cancel with these particles, which remember, these particles can be atoms, they can be formula units, and they can be molecules. So molecules cancels with molecules. Okay, so this is written with 1 mole on top. We're going to say specifically the substance is CO2. Okay, 6.02 times 10 to the 23rd is on the bottom. Particles, but we're not going to say particles because we know these are molecules. We'll write molecules. And we're going to write of what substance? CO2. Okay, the CO2 cancels and the molecules cancel. I could have done that in once, but I didn't. Okay, now we're going to do the math. So I'll write down how that's done. How I put it in my calculator is this. 1.85, the times 10 to the power of, I can take care of with an e to the 26. So 1.85 e to the 26, we multiply the numbers across the top, so times 1, then I hit enter. Hit enter, don't just leave it. And then divide by the number on the bottom. If you don't hit the enter, you might divide by this or multiply by this fraction, and that'll make your number kind of funky. So just make sure you hit enter. It's not so much a big deal with the 1, but here we go. 6.02 e to the 23, and hit enter again. So let's see what that looks like. 1.85 e to the 26 divided, times 1, hit enter. Changed it a little bit. Then we are, oh look, I messed up. Hit enter. I didn't say what I was doing with that. I need to divide. That goes right there. Divide by 6.02 because that number's on the bottom, so we divide by that. You multiply the numbers across the top and divide by the numbers that are on the bottom. Okay, I got 307.30, a whole bunch of things. So let's write quite a few digits past the decimal. 307.30897. I'll stop there. Okay, let's count significant figures. Remember that in scientific notation, the only part that counts is the number in front, right? The coefficient. There's only 3 significant figures. I tend to like 3 significs. Okay, there's only 3 here, so this answer should have 3. We start counting at the first non-zero on the left. So it's 1, 2, 3. So I'm going to chop it off right here. And check to see if this 3 can bump up that 7. It cannot. So this is 307. We didn't cancel moles of CO2. Everything else got canceled. So for units, a mole of CO2 is my answer. Okay, and that one is done. All right, a couple things to note. You never change these in front, right? 1 is going to go with the mole. 6.02 is going to go with whatever type of particle, atoms, units, formula units, molecules. I never want to see 6.02 moles. Oh my goodness, my conversion factor is wrong. And I've been using it this whole time. Well, I'm not going to start over the video, guys. So 10 to the 23rd. So 6.02 times 10 to the 23rd particles. This one was right. This one was wrong. So if you made a card, fix it. Okay. All right. I hope you understood that. If not, you need to make sure you write down some questions.